Good morning, everyone. Welcome you all to DOBOT User Conference. My name is Xie Jun Jie. I'm going to share, because I'm the product director, and I'm going to share with you some latest information about DOBOT products and solutions, and the future plans of next year and the coming years. So today's content including two parts. First, I'm going to have a review of the product development of the past years. And so in the past over years, and we have launched a few new products, and also we have keep continuously optimizing and upgrading our hardware and softwares, and launching new solutions to the market, and including our latest CRA series, which is the second generation of our cobot, 6-axis cobot. And besides that, we also have our 2.5D camera teach pendant, and we also launched palletizing and welding solutions to our market as well. And besides all the hardware, and we also have software, new softwares, and a lot of them are also validated and refined in the real world projects. So it's not just a redesign, but the most importantly, validated through the projects. So the first thing I'm going to talk in detail is about our CRA series. The A stands for advanced. So it's like a enhanced version of our CR robots. And in this new CRA series, we have also extended the capability of payload. And we have the latest model of CR20A, which are mostly used in palletizing solution, and sometimes heavier object loading, unloading tasks. And we can also use it for AMRs, on AMR to carry out some heavy object. And the improvement is in all directions. So first of all is the performance. And the CRA series has higher speed. And the obvious one is maximum joint speed. Some of the maximum speed improved from 180 degrees per second to 223 degrees per second. But most importantly, we also increased the acceleration rate. So maybe this parameters is not listed on the parameter tables, but this is more important to the performance of a robot actually, and it's more relevant to the cycle time. So if you have higher acceleration, the robot can reach higher speed in a very short time. So especially when you do some complex work and the robot is not moving a long distance, but short distance in a lot of different trajectory. And that's why acceleration make more efforts to the cycle time. So if you have a higher acceleration, the cycle time will be shorter. And safety is a top priority for a cobot. And for the CRA series, we have redesigned the safety controller. So from the hardware perspective, you have a new safety controller. And on the software perspective, we also increased the safety functions up to 22 safety functions, including safety wall and speed monitoring and power monitoring, and also you can set limitation, and also functions like reduced mode. And besides the safety functions, and we also have the electromagnetic brake. That's also a big improvement from CR to CRA. So we all know that in the first generation of collaborative robots, or at least most of the cobots you see on the market today, they are using this kind of pin brake. So if you push the emergency stop, or if you disable the robot from empowered to unpowered state, and the robot will drop a small distance. But in general case, it's okay. But when you press the emergency stop, if the robot shifts a little bit, or it drops some distance, for example, 3 millimeter or 5 millimeter, then it could injure the people, or sometimes you injure the end effector, or you injure the work, you damage the workpiece. But with electromagnetic brake, and the drop distance could reach less than 0.1 millimeter. So if you press emergency stop, the robot will stop and immediately, and the drop distance will be unnoticeable. So that's a big improvement. And the third part is about better expandability. So with CRA, we further increased the numbers of I/O. So in CRA, we have 24 I/O, and we also the safety I/O reached up to 10. And so in that case, you can make the safety functions or safety strategies much more easier. And we also support PNP and NPN switch. So for system integrator, it would be more convenient. And we also support Ethernet MP and Profinet in CRA series. Besides all the obvious part of obvious improvement of CRA, there is more fundamental and more important is the controller. Actually, for the CRA, even the CR and the CRA looks very similar, but the CRA has a redesigned controller architecture. So with the new architecture, the CRA has better stability and better scalability. So if with the new architecture, we can make the robot more robust, and if we want to add new functions, it will be easier. And we also have, for the past 8 years, and we have continuously optimizing our production process. And since 2021, we also had our own factory. And throughout the years, we have accumulated experience about assembling and testing to make our robots more with higher quality. And there is more. For example, the smaller cabinet, so less space occupied, and more accessories such as the cameras and the teach pendants. I'm going to talk next. With CRA, we also launched our new platform of the software, and the DOBOT Studio Pro V4. And this is a redesigned software from the scratch. So it has a redesigned user interface with better user experience. And so you can find the required functions more easily and with higher efficiency. And we also embedded all the manuals inside the software, so you don't have to download the software and the manuals separately. You can look into the manuals inside the software. And if you have some doubts in the functions, you can quickly find out the relevant explanation. And we also have a redesigned log system with much more information. So if you are a system integrator or a user, and when you debug with the robot, you would find it very useful. And we also have multi-language support. And for example, for Japanese, Germany and France and South Korea and Thai, etc. Of course, we are still optimizing the translation. Now we have it, but we are continuously optimizing the translation. And for our DOBOT Studio Pro, that's also one of our big advantages is we have Blockly, and Blockly is very easy to use, very easy to understand, and yet very flexible. So it's like a combination between flexible and easy to use. And we also have script programming with script programming for more advanced programmers, and they find script programming is more efficient, and also especially in some very complicated applications. The next one is VX500, the 2.5D camera. And in 2023, we had some projects with cameras, especially with cameras with AMRs. So it's very challenging for the system integrators to deal with three kind of systems: the AMR, the vision system, and the robot in the same time. And a lot of cases, we have some partners or some integrators have difficulty in solving the vision problems, and we will give them support. And in that case, we want to make vision system much easier. So we made the VX500, a smart camera. The smart camera means you don't need to have another industry PC to process the vision. And the smart camera means the camera and the processor are inside the small body. So you don't have to have another PC to do that. And so the benefit of this is it's much easier for users. And the key functions is we have this 2.5D positioning functions, which means you have a landmark and you can put the landmark anywhere. And if the camera takes a picture of the landmark, and the camera can set a user coordinate of the position. And so, for example, if you have a mobile platform, if you want to change the workstation from one place to another, and so if the robot moves to a new place, and it can use the camera to take a picture, and based on the landmark's position, and the robot can find the right space to do the task. And it's also very useful for AMR applications because we know AMR move between different places. And so each time there is like a 10 millimeter or 5 millimeter offset, and with this camera, and it can find the right position again. And the accuracy could reach 0.26 millimeter. So it's very high performance and very high accuracy. And the camera is fully integrated with our robot. So with the small wire, by the end of the robot, you can directly connect to the end interface, I/O interface of our robot, and you can connect it, and you can find the whole vision functions inside the DOBOT Studio Pro. So you don't have to open another software and set up the communication between one software and to another, but you can program the robot easily inside the same software. And the VX500 also has a lot more functions, for example, for pattern recognition, for barcode reading, for OCR, etc. So it's not only limited to the 2.5D positioning functions. There are more to explore. And our Xie is good at the PC software and also the mobile platform like iPad or Android Pie. But still, for industry robot users, they are more familiar with teach pendant, and especially in some industry environment, there is a lot of magnetic electric noise, or if there are a lot of mechanical parts, and if you connect the robot with wireless or cable, it may be not as stable as wired connection. So we had this new teach pendant. With a new teach pendant, you can connect to the robot with a wire, and as long as the wire is there, the connection will not be interrupted. So it's more stable. And with the teach pendant, you also have this 3-position switch. So in this case, for factories with very high safety requirements, you can have this manual mode and automation mode switch. Generally, in most cases, for cobot, it's a switch from manual mode to automotive mode automatically. So you don't have to switch by the operator. But in some factories, and if they don't accept this, they have to have this very strict requirements to set off this kind of switch manually. Then they can use this teach pendant. And with the teach pendant, it also comes with 12 physical buttons. So for some very complicated applications, if you need to set up some point for more than 100 or even more, and the jogging process is very time consuming. But with the physical buttons, and if you use it for a while, and if you are very familiar with it, then it becomes very efficient. So that's teach button. And we also had the palletizing solution. We launched this in the beginning of this year, and in this year we have more than hundreds of palletizing solutions running in different factories. And in the next speech, our colleague Tamara-san will talk more about palletizing solution. So I will skip this part. And the next one is welding. Welding is usually done by an industry robot, but for cobot, because it's very easy to use, and you can have it has this hand guide teaching functions. So you can hold the robot to the right position, and you can teach the point. In that case, for the welding, if you want to teach the robot about the welding path, it will become much more efficient. And the cobot is also lightweight, so you can move the robot to a different place. And especially we see in shipyard, in some steel manufacturing factories, and people put the robot on a magnetic seat, so you can attach the robot to different place. And we also have some multiple arc switching models, and we have also during the year we also developed some advanced functions for welding, such as laser torch positioning and laser tracking, laser positioning, and multipass welding, especially for thick steel. You need to have this multipass welding, and we are also compatible with more than 30 welding machines, and the numbers is still increasing. And lastly is DOBOT X-Trainer. DOBOT X-Trainer is a platform to explore the imitation learning. That's also one direction we are trying to explore. And this is a platform with two master hand or so-called premier hand. And this hand is used to operate the slave hand. And here we use Nova 2 as a slave hand because of the high precision. And by the end of the slave hand, it has also a very general purpose gripper. And there are also 3 2D cameras. One is on top of the framework, and the other 2 is at the end of the robot arm. So, what is X-Trainer? I will explain with this video. So generally, robot is very good at a standard and repetitive task, especially some standard process. And to do that, we also need to have like a very standard environment or so-called structured environment, which means it's very standardized. So the robot knows where is the object and where to put the object, and the environment is constant. But the challenging is that in order to do that, you need to set up the environment for the robot, and you cannot make changes. Or if the environment changes a little bit, you have to reprogram the robots again. For example, if you, for example, for the sensei machine turning, if you put a cube inside the machine, it's one program. But if the object changes a little bit bigger or a little bit smaller, you need to reprogram the whole process. But with AI developments, and the situation could be different. In this case, we can see the 2 Nova is folding a t-shirt. And that's not very difficult for industrial robot without AI because the clothes is not not a rigid object. And there are also some other examples, for example, pouring a water into a cup, and also to handling this ping pong balls on the pedal. And but with large language models, you can train the models, and the models control the robot based on the vision perception. And how is it? I'm going to talk about that later. So this is a part of introducing what is the hardware. So this is like 2 premier hand, and you can hold the 2 hand to manipulate the slave hand. And there are cameras on the slave hand, on the Nova. So during the process, the cameras will take videos. And this is part how we train the robot to do such a task. So first, I'm going back a little bit and explain this again. So basically, you use the 2 master hand or premier hand to operate the slave hand to do the work, some kind of teaching. So you teach the robot how to do folding a t-shirt. And during this process, we will record the movement of the robot, the trajectory, the point, and also maybe some other data. And in the meantime, we also record the videos from the 3 cameras. And based on this input, and we train the robot to do this we teach this robot to do this task for some times. For example, for 50 times, for 100 times. At least for now, we need to have a lot of data to train the robot. And after training, we put all this data with this large language model or some special AI models with robots, and we train them and refine the models. And after that, the robot can do the whole process based on the vision feedback. That's how we do it. But it's still the early stage of this exploration, and this is a platform for exploring this possibility and also collecting data and do the training and to find out what's next. And we all know that the AI is developing very fast, especially with this large language model technology. And in this direction, there are also a lot of models are designed for robot manipulation. That's kind of a direction we are trying to follow. And with these AI models, I think in the future, people don't need to program the robot point by point or trajectory by trajectory, or you need to set up the I/O on/off at a very specific point. You just need to show how the work is complete, and the robot can learn from the cameras or the other sensors, and the AI models can control and program the robot automatically. So it's totally different from what we do with robot today.
Hi, X-Trainer.
So what's the future plans for DOBOT? Basically, the direction is higher performance, because we know COBOT is a very generous purposed tool. So it can be used for machine learning, for welding, for a lot of other applications. And so better performance is our pursuit. And collaborative safety is the top priority, as I mentioned. Especially we want the robot to work side by side with people and make it easier, not just easy to use and easy to integrate. And finally, become smarter. So we spend less time to teach the robot how to do new work, make it more flexible. So the first thing we have is like the improvement and the upgrade of our CRA and DOBOT Pro. Actually, in the January of next year, so in next month, we are also going to have one more new version, and with the new version, it's like a big upgrade and a lot of new functions like enhanced force control, and we have also improved safety features. Even CRA improved a lot, but we are continually improving the safety features, adding more safety functions. And lastly, we are also improve the efficiency. We have this optimized trajectory recovery functions. For example, if the robot stops somewhere in the debug mode, and you can stop there and change the environment and recover the trajectory and continue the debug. So you don't need to start over from the very beginning. And there are a lot more for the softwares in detail. And the second part is software. Software is like the soul of hardware. So, and the software enrich the functions of the robot. And for next year, we also will have this online virtual controller. So basically today, if you want to try our DOBOT software, sometimes we want to show our software is easy to use, but we have to control the software to a real robot in order to use it. Or sometimes if we just want to program the robot first and then we move to connect to the real robot to test it. But that's why we have this online virtual controller. So basically you can on the standard software, you can just set up some connection into connected to a website, and then it can connect a robot controller in the cloud. And in that case, you can try the software and you can program the robot without a real one. And the next one is the simulation software. Basically, we already have a simulator for the palletizing workstation at this moment. So with the simulation software, you can simulate the reachability. For example, you have a palletizing application, you can set all the parameters inside and run the simulation. And next year, we will have a more generalized simulation software, and so you can set up the working environment and you can program the robot and see how it is going inside the simulation. And lastly, we are also going to have a DOBOT Connect. It's like a remote monitoring and debugging platform. So today, if some robot is there's trouble with the robot, sometimes we have difficulty to get the log file, or we have difficulty to find out the problem and solve it. It often takes several hours or even days to solve the problem. But if we have this cloud connection, then we can do all this debugging and problem solving online, and it will be much helpful. And next one, we are going to have our higher payload robot for 25 to 30 kilo payload. And this, the detailed parameters is not reviewed at this moment, but the general range is 25 to 30 kilo, and the reach is 1.75 meter to 1.85 meter, and still very good repeatability. And this new robot will be launched by the end of next year. And the target application is palletizing, especially today when we are promoting our palletizing solution. In some factories, there are box with 22 or 23 kilo. That's be a little bit more than the 20 kilo payload robot we have today. And also for some heavy object loading, unloading tasks, like for example in the car industries, for some engines or for some heavy object. And another important thing is about the DOBOT Plus, more plugins. So collaborative is targeting at small batch but high variety products, and in that case, to make the redeployment much easier is very important. So we want to make the system integration much easier. And in order to do that, we need to have a very standard hardware and very easy softwares, very convenient softwares. That's what we call DOBOT plugins. And DOBOT Plus. With DOBOT Plus, we're going to connect to some robot makers or some other gripper makers inside the industry, and we are going to cooperate with them and make the hardware standard and make the software plugin inside our software, so you can connect to the hardware directly and control the hardware with the plugin. So you don't need to have a very complicated manual and take hours to research what's the communication protocol of the grippers or the sensors. So you can just use some blockly command to directly connect to control the accessories. And so first off, all we have this open protocol at this moment. So if there are some companies they want to develop a plugin for DOBOT, they can do it by themselves. That's the first part. We have fully opened protocol to the third party. And the second one, DOBOT will also actively work with some partners to develop plugins for end tools, sensors, lifting column, and also smart screwdrivers for the next year. So that's all for today's for the next years. And so we have CRA and our DOBOT Studio Pro, the hardware and the software, the continuous upgrade. And then the other softwares, we are going to develop more softwares for our robots, for simulation, for the pre-sales. Before you have the real robot, you can simulate. You can use a virtual controller to try our software. You can use simulation to validate your application. And after the robot is implemented in the real environment, you can use DOBOT Connect to monitor the states and solve problems. And we are also going to have higher payload robots and more plugins. And finally, we are also going to explore in the AI and imitation learning direction to make the robot smarter. And that's also important for the future. That's all. That's today's all the content. Thank you very much.
ありがとうございました。